Alright guys, welcome back to another LeetCode video. So today's question is called lowest common ancestor of a binary tree. And so it says, given a binary tree, find the lowest common ancestor of two given nodes in the tree. And according to the definition, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. And we will also allow a node to be a descendant of itself. So usually I would, go through the examples and whatnot, but I think for this problem specifically, the prompt can get kind of confusing. So I want to try something different here and kind of whiteboard this out and go through some terms with you guys. So hopefully it'll make more sense. Alright guys, so I think the first step in understanding this question is we first need to figure out what exactly is a descendant. So if I were to ask you this question, let's get out the pen here. If I were to say that, P is 1, and then I said Q is 12. And I asked you, is Q a descendant of P? Well, the way we're going to figure that out is this. Essentially, a descendant will be any node in the path from P to a leaf node. So what do I mean by that? I mean that if we trace any path from P, right? But not just any path, the path has to be to a leaf node, right? And in this case, 12 is a leaf node. So if you trace a path from P to a leaf node, on the way there, if you find Q, you can make the claim that Q is in fact a descendant of P, right? So we see that if we trace the path from 1 to a leaf node, right, we do in fact find 12 on the way there. So let's do another example. Rather than 1, let's say that P was 2. Let me ask you, is Q still a descendant of P? Well, let's find out. So we trace a path from P to all of its leaf nodes. In this case, there's just one here, and we see that the leaf is 28. On the way to 28, did we ever stumble across 12? Right? The answer is no. So we know for a fact 12 is not a descendant of 2. Alright guys, so now that we know what a descendant is, we pretty much already know what an ancestor is, right? So for this slide, I'm not going to do anything different. We're going to say, let's pick blue here. We're going to say that P is 1, and then we'll say that Q is 2. Now, if I were to ask you, is P an ancestor of Q? What would you say? Well, what if I said this? Is 2 a descendant of P? Right? I think you already know the answer to that question, right? If we trace this path from 1 to 2, okay, we find 2 along the way to 1's leaf nodes, right? So you can make the claim that since 2 is a descendant of 1, you know that 1 is a ancestor of 2, right? And that it makes sense too, right? So in that case, we're good. Now let's say that P is 2 and Q is 8, and I asked you, is P an ancestor of 8? Well, maybe. I mean, 2 is above 8, so it could be. So, maybe it is. But then, I told you, go through the example we did before, right? Trace 2 to any of its leaf nodes. Boom, boom, no leaf nodes, null, right? So, on the way from 2 to all of its leaves, which don't exist, we don't find 8. So, there's no way for 8 to be a descendant of 2, and likewise there's no way that 2 is an ancestor of 8. Alright guys, so now that we defined our key terms, we can finally start getting into some examples. So let's say I asked you, what is the lowest common ancestor of 12 and 8? Well, we know our two possibilities are either 1 or 3, right? So we know 1 and 3 are ancestors of 12 and 8, but our question asks us which is the lowest. And, just visually we can see that 3 is lower than 1, so of course we would pick 3. But now this begs the question of what is our algorithm going to look like to actually solve this problem. So I can give you guys a rough draft of what we're going to be doing. So first we're going to start at root no matter what. We're going to start at the root, and our second step, we're going to branch left. And if you're not comfortable with the term branch, all I'm saying is like search left if you want to use search instead of branch. After we branch left, we branch right. So this is the very high level idea of what we're going to be doing here. So let's see how we get to this answer of 3. First, I told you we're going to start at the root. Cool. After after we start at the root, we're going to branch left. And we're not just branching for no reason. We're branching until we either find P or we find Q, or we just hit null. So we see when we hit 3, is 3 equal to 12 or 8? No. Keep branching left. Just do the same thing over and over. Is 12 equal to 12 or 8? The answer is yes. So since that's the case, once we find P or Q, we need to bubble that result back up. So we return 12 on 3's left half. And now 3 says, okay, I explored my left. Now I have to explore my right side. So we're just continuing. We're just doing steps 1, 2, and 3 over and over. So first, branch right. Is 8 equal to 12 or 8? The answer is yes. So since we did find P or Q, we bubble up that result back up to 3, and we return 8. Now 3 says, okay, I got a not null node on my left side, and I got a not null node on my right side. So if we run into that case, then 3 must be the lowest common ancestor. So once we find that lowest common ancestor, all we're going to do is bubble that result back up to the top, and we return 3. And so at this point, our algorithm doesn't know that we found the lowest common ancestor already, so we're going to actually end up exploring the right half too. So as I said, just keep branching, and we see that on this path we didn't find P or Q, so eventually we just hit null. And after we hit null, we're going to bubble that all the way back up, which will be a null value. And so now, if this is our case where we have a not null node on the left and a null value on the right, we're just going to return whatever value is not null, which in this case is 3. So 3 is our answer, and we found the lowest common ancestor. Alright guys, so this time, let's say we were asked to find the lowest common ancestor of P equal to 3 and Q equal to 2. Again, we're gonna keep repeating steps 1 to 3. First, branch left. Oh, it looks like we found P. So, as I said, once we find either P or Q or null, we bubble up that finding. And so, one's left half is going to return 3. Cool, so now we still need to explore the right half. So we branch right, and immediately we find 2. So we just bubble up our findings back up. And now 1 says, okay, I have a not null node on my left, I have a not null node on my right, Thus, I have to be the lowest common ancestor. So we would return 1. Alright guys, so now at this point, let's say we wanted to find the lowest common ancestor of 3 and 8. So we kind of already understand the process, so I'm going to speed up a little bit. So first, branch left in search of 3 or 8, and we find 3 right away. Cool, since we found either P or Q, bubble up our findings back to our caller, return 3. 1 says, okay, my left half is done. Cool, now I have to branch right. So I'm going to branch right in search of P or Q. Okay, this isn't P or Q, branch right again, this isn't P or Q. And then we branch again, we hit nothing, and as we know, once we hit null, we bubble that finding all the way to the top, and we return null. And now 1 says, okay, I have a null value on my right, I have a not null value on my left. So in this case, I'm just going to return the not null value. So we know in this example, 3 would be our lowest common ancestor. Alright guys, so just from the few examples that we did, we could already see a few cases forming. So case 1 would be that we find the lowest common ancestor at P or Q. So for example, if I told you to find the lowest common ancestor of 3 and 12. First, we saw in our high-level algorithm, we're going to start off by branching left. And so we said, if we find P or Q, just bubble it right back up to our caller. So we found 3, return it back to 1. 1 gets a 3. And then, as you can clearly see, like on 1's right half, it's just going to return null, because P and Q are not present. So in this case, we would just return the not null value. So this is the case where we find the lowest common ancestor equal to P or Q. Alright guys, so case number 2 would be if P and Q are not in the same half. So this is what I mean. If I told you to find the lowest common ancestor of 8 and 2, what would we return here? We already know, first thing we start at the root, and step 2 would be to branch left in search of P and Q. Branch left, we didn't find P or Q. Branch left, we didn't find P or Q. And at this point, we would just hit null. And once we hit null, we have to bubble up our findings back up. Oh, not that far. Rather, it would just bubble up to 3's left half. So I'm going to write N for null. And now 3 says, okay, well, at least let me search my right half just in case it's on that side. So we branch right. And at this point, we do find 8. So once we find 8, we have to bubble up our findings back up, and we get 8. And so 3 says, okay, I have a null value on the left, not null on the right. Let me pick the not null value to bubble up to 1. So we're going to return 8 on 1's left side, and now 1 still has to branch right. So we branch right, and right away we find Q. So once we find that value, we have to bubble up our findings all the way to the top. We have a not null on the left, not null on the right, thus our answer has to be 1. So this will be the rough outline of our algorithm. We have a method called lowest common ancestor, and essentially step 1 will be, if the root is null, or the root's value equals P's value, or the root's value equals Q's value, we're just going to return that root. In second step, we're going to explore the left subtree and in search of P or Q. And then if we do find P or Q on the left, we're just going to return, we're going to return it back to its caller. Otherwise, that means we hit a null value and we would return null. And like we said before, like we're not doing anything different. After we branch left, we branch right in search of P or Q. And again, it's the same process there. And then we need to note that if the left or the right subtree of the current node returns null, we know that current cannot be our lowest common ancestor. So that's kind of the rough outline of the algorithm. Let's actually get into writing some code. Alright guys, so as we said before, our first step, we actually need to do some housekeeping. So we first need to check if the root is null, or if the current root that we're sitting at's value is equivalent to p's value, or the current root that we're sitting at has a value that's equivalent to q's value. And so all this is saying is, like, if our current root equals p or q, we know that the current node that we're sitting at must be the lowest common ancestor. So in this case, we're just going to return the root. And the reason for this is because of this rule right here, where we will allow a node to be a descendant of itself, right? Okay, so after we take care of that, we actually need to branch left, and then we need to branch right. So we're going to have two variables here. Left is going to be the result of branching left. So let me just copy this guy. We're going to pass in not the root, but actually root.left, because we're going left. P will stay the same, and Q will also stay the same. Make that look a little bit better. So this is our first variable, which is the result of branching left. And as you might have guessed, we also need to branch right. So we're going to save that result in this variable. So we branch left or right. We have a few possibilities. Left and right could both be null. Left and right could both be not null, or just one of them could be null. So we need to address like all of those cases. So first of all, if the left is not null and the right is not null, this is kind of the easier case because we can just return the root that we're sitting at. Why is that? So if I told you to find the lowest common ancestor of 5 and 1, you'd first begin at 3, you'd branch left, and you'd find 5 right away. So you'd bubble 5 back up, and then you'd search 3's right half, you'd find 1, and you'd bubble 1 back up. So since we have two not null values, you know that the current root that we're sitting at must be the lowest common ancestor. Right, so we gotta address our other cases. So let's say that left is null, and the right is also null. So in this case, we would just return null, because as you might have guessed, this kind of means that like we didn't find P or Q during our search, in which case, since they're not present in the tree, just return nothing, right? And finally, if only one value is null, so like if left is null and right is not, so let's do this. So if left, or let's say like if left is not null and right is null, we would just return left. And you know, vice versa, if right is not null, we would just return the right. And so what do I mean by that? I mean, if I told you to find the lowest common ancestor of 6 and 2, right, you would bubble 5 back up to 3's left, because as you can see, like 5 is the lowest common ancestor here. So on the left we'd get 5, on the right we would get null, because 6 and 2 are not present on the right side. So whichever return value, whether it be left or right, is not null, we want to return that to our caller. So let's run this just to make sure it looks okay. Looks good so far. Let's go ahead and submit. And we're good. So it's faster than 100% of the solutions, which tells us that this is indeed the optimal approach here. So yeah, guys, let me know if you want more of these kind of like whiteboarding type of videos. I feel that with the whiteboard I can give like a lot better explanations. So yeah, I hope you guys enjoyed this. I hope it was helpful, and thank you for watching.